Welcome to today's episode of AI in Action, where we decode the latest trends in AI, from research to profit, the Applied AI Show. Your hosts, Rajan, founder and partner at the AI accelerator Upeka and involved in AI research, and Kashi, AI researcher, startup founder, and renowned AI voice, bridge the gap between breakthrough research and business results. Rajan brings deep expertise and AI-first transformation and emerging architectures, while Kashi contributes hands-on experience with research and implementation by building and deploying AI systems across industries. Together, they decode the latest developments in AI and agentic systems and translate them into actionable strategies for practitioners, founders, and business leaders. Their mission: help you turn cutting-edge AI research into real-world ROI.
Start of this podcast, we thought we'll also cover deep research. So I want to start our foundation towards that section. Um, I think I particularly got interested in this paper. I know I'm reading it pretty late from DeepSeek on the MHC, which is Manifold Constraint Hyperconnections. It's tracking a breakthrough that could shape how AI
Tell me
models.
more on that. I'm behind on reading that as well. And Kashi, one thing that we should do is that
Yeah,
we should also address some of the questions that we got from the previous podcast. And we'll come to that
yeah,
later. In terms of
yeah.
just give us a very high level description of what each of these terms means. I know people asked us about mixture of experts. We can come back and answer that. I
Yeah.
like your analogy a lot. But why don't you actually uh, describe this from okay, here is what ELI 11 version means of this term, and then tell what are one or two, three key insights from the paper.
I mean, the way I think DC described it really well in layman terms. They talked it about, think of it like a multi-line highway with a lot of intersections, and car can change lanes, merge, split with increasing flexibility. But the total amount of traffic or information must remain constant, and nothing can explode and vanish. And that's how they sort of described it. And so the real breakthrough in this approach is nothing but we can bypass bottlenecks in terms of how one stream can connect to another, and it accelerates token generation, reduces cost, increases flexibility. That's how I see it. The other paper I was actually looking at is like, I'm sure we have all experienced it, is context decay. And actually,
Yeah.
the thesis was that, hey, context decay is actually useful. Like, it also acts like humans, right? We forget what happened yesterday because it's sort of not relevant. And context decay in some form accelerates models' ability to learn and remain consistent. I think we should deep dive into it a little more
Yeah, I remember
in time
you
to come
forwarding that.
because it's a promise that we had
Yeah,
to our audience. Yeah.
yeah. I remember you forwarding that one video from AI engineering. I remember I was in the audience in that one where he talks about um, by the time you reach 40% of the context, you're already losing a lot of things, right? And most people don't understand how much of context that you're using. In fact, one of the debates that I hear is that people using the official Ralph Wiggum plugin and the Jeffrey Huntley's Ralph Wiggum plugin is to say that the approaches is different. There they don't reset the context in the simple loop that Huntley suggests. Yeah, reset the context, and resetting that context is what is very important when you're doing multi agent work. So why don't we actually spend some time? Can you explain what context is and why this matters?
I think, and probably will bring to the human world to understand context. So when we are working on something, let's say we're working on an Excel or a piece of code, we have sort of a memory map of what is happening within that particular piece of work within our brain. So we can correlate that to a simple thing that a program does, and we call that context. Now, while we are working on it, a lot of different ideas spawn within our head on how to solve a particular problem or how to get work done. So that's where our context starts to spawn. Like in school, when we are listening to the teacher or working, we sort of daydream, go into multiple possibilities. And sometimes we don't come back to the original train of thought. And we often use this phrase as humans, right? Oh, I lost what I was speaking, or like, I'm lost on this conversation. So same thing happens in terms of when you're dealing with models in reality. So that's and that has implication on the work given to the model, which could be the code generator or the Excel that's being worked on, so on and so forth. And often there are multiple ways to deal with it. One of the ways I deal with it is like halfway through, like I know that context has reached about 40-60%. I sort of have a compressed version of the context that I reload and add it to the flow of path, because a context has got enriched by design. That's one way to deal with it. The other way people deal with it is just compact it, which is coming natively in Cloud Code. They sort
Which
of purge
actually
it.
is, which is
Yeah,
actually hotly debated, right? Some people say that, that's one of the terrible things to do. What is your take?
I think it depends on the situation. You have to have a sort of hunch around it. Let's say you're doing a single page program and like you're trying to solve a narrow problem. There's a lot of benefit in carrying forward that context by just compacting it. The returns are manifold. Um, I think because you don't sort of like have to deviate. The deviation in the context is what you are actually looking for than actually the original context. But in certain cases, like let's say you have to reload everything and give it a full refresh, because you've deviated too much and you don't know where you are, and you have to sort of refresh, and happens. Three ways a developer might have realized it is, um, you would have told it not to use any libraries apart from the few open source libraries you have listed. It will go create its own library. And you'd say, no, I want to use Apache eCharts. I want to use like this library. Why the hell did you create this new charting design on the screen? I don't want it. And oh, it'll go fix it and it'll go create something else. So in such a case, it's like, you know what, just purge the context and start. But other example of it where you want to retain, like let's say you're solving a deep algorithm problem where you're debugging a memory leak. You almost know it's there, so it's like it's better to compact and add information to it to enrich it. So I think, yeah, I think it's still a bit of field today, but I think this is a short-term problem. I believe that this
So
is
the
not
two
going to be a
parts to
sustainable
this to extend
response.
it, right, Akashi? One is the developer version of this, which is like, as developer, and I think most people don't get it, right? They just blindly do like, press tab. So they don't understand how important it is to manage manage context, right? Normally they would just do compact, right? So one is like, talk a little bit about the tools that you use. One, you talked about the approach. Other thing I would say is like, what is the COIO implication for this? Like, what's the leader's implication for this? Saying, look, you're bringing in AI coding tool, you're bringing in agentic engineering into your organization, and context becomes important, right? So, like, is there a CIO perspective to this? First, the developer one.
Yeah. So in fact, I think our friends at Sign Easy, we met them and then like sort of debating with them. So one of things we started to like inculcate this, right? As a CIO, you might, or even like a general engineering leader, you have to teach your team on how to manage it. So like we go to the first principles. How do you solve a large problem? You break that large problem into smaller problem and you try to solve that. Or if it is still large enough, you still break it into a smaller problem. Now, like extrapolating that into into actually organizational context, again using the context but in a different way, is that maybe your deployment strategy changes. Your code repo, which was like say 10 repos, now has to become 20 or 30 repos, so that it doesn't the AI can better understand and it doesn't run out of context, and you have a sort of like
Okay.
orchestrator.
That's very
That's
interesting.
one way.
Just to interrupt, you said 10 repo becomes 20 repo and not a mono repo.
Oh yeah, yeah. This is not me. You can go and like look at internet on how people are solving the context problem. The only way they're solving it is they're breaking it so that AI can hold that amount of content in its memory. And one repo, I mean, the way, let's say, two RESTful APIs, both are backend repos, interact, they interact via REST API. So the contract, this a lot what we have done. Contract is exposed via documentation in some sort of MD file, or like you just give it access to the Swagger. So that can be at runtime, knowledge of the other repo can be exposed or compacted and kept. So which will be in few KVs or maybe a couple of MBs. Uh, and then the rest of the repo, which is becoming very specific in solving the problem, happens. Again, this goes back to what Peter did, right? Peter lets agents code and he doesn't even need to review it. Like the question is, how do we achieve that, right? So that's a debate that we were having. A great way to achieve that is by doing two simple things. One is breaking the repo. The second is creating a test DB only for agents, which will have the context and the data associated with it. And by breaking the repo, you're doing the most important thing, which is reducing a blast radius.
Yeah, I was gonna say that
If you
blast
break the
radius
10
thing.
into, yeah, it's a sort of reducing the blast radius. So at max, if your agent goes wrong and accidentally pipes into it, and you probably have only to lose like that one or
That small
two.
small blast
Uh,
radius thing.
yeah,
Yeah.
so that's another impact of it. So that's how people are tending to deal with it. Like it may not be 20, it may be sometimes 40. Um, but there's a method to it. It's not just reducing the size, but doing it in business domain and business value. For example, uh, it could be related to, let's say, a particular part of the supply chain, and those APIs have to live together, share common library. I think it's best done that way on the same case in fintech, so on and so forth.
So you're saying
Uh,
deployment strategy will change. What else?
Deployment strategies will change, security strategy will change, training strategy will change, and of course, I must say this: the amount of workforce will change. You don't require so many once you sort of divide your repros. Probably if you had like 50, 60 engineers, you might have to bring it down. Again, there'll be cases where this might not be possible, but I strongly believe that um, I think from a CIO's perspective, once this is put in place, I think the CIO is all about reducing the risk and increasing the velocity. Now, once the risk is distributed, uh, I think he or she will get a lot of confidence that this problem is now under control, and then slowly the rollouts will increase. So definitely workforce reduction is one of the indirect impact of better context management.
Got it. Going back to the research that you talked about, say a little bit more about that DeepSeek paper.
Oh, I just started to read about it. I think I'm still in the very early.
What's the impact for CI, right? For me, one of the things from an
Yeah.
enterprise and a CIO perspective last year for DeepSeek was just more about saying, look, now everybody needs to start thinking about their own model building, right? So there is a downside of DeepSeek, which is like Chinese model. A lot of enterprise leaders will not want to trust it, despite you tell them that this is an open weight model. You're going to put it in your own environment, but still people will doubt that data may go out, data may come in, etc. Right? But what it did was for the first time it said that building model does not take hundreds of millions of dollars. You can do it in, let's say, like a few $10 million within in the realm of reach of enterprises. And now if you're seeing whatever is happening with Cursor and Perplexity and others, and many other applications, it makes even more sense for every AI company to build their own models, or at least to, do fine tune of their own models, so that they're not dependent on just the API provider. So what is the insight from this Jan 1 paper? What's the implication for enterprise on the DeepSeek?
I think I got interested into it, like my goal, which I've been chasing, right? Um, as an organization, how do we reduce the memory footprint a model really takes to train, scale, and then sort of deploy? Because today we are living in a memory constraint world, and you read my research paper on that and open support. But I do see that the great implication of it is like reduce training overhead times, which means I don't need to buy additional hardware at the rate at which I used to buy before. That's one, at least 6 to 10% I see as a reduction. That's huge, like when GPU prices are climbing sky high. The second one I see is like, if that happens, it is also accelerated uh, time to market. So, and these are the two things CIO often chases. How do I keep my costs low? How do I ship things faster to market? So I think that's how I see the real world implication of that paper spawning out. I am sure when the new version of DeepSeek, which is just around the corner, comes in, we'll see what it really resulted in. But I think the cascade effect is like, I think, I see to be very positive in terms of how AI research would evolve.
Have you tried their OCR that they released last week? DeepSeek released
Not
an
yet.
OCR.
I have been chasing Alan AI's
MOE
releases.
models.
Yeah, MOE, and they also released a new agentic version which helps you train on your code basis. So I somehow feel the work Alan AI is doing is going to be super impactful for everyone in the industry. Um, I'm surprised that I
So
had not
on that
spotted
note,
them earlier. Yeah.
yeah, on that note, Kashi, why don't you actually explain what MOE is? Because after the last video, people came to us and said, "Hey, what is MOE?" I liked your hospital example. Can you explain MOE using their hospital example?
Um, I think the way we need to sort of interpret MOE is like we go
MOE
to
for MOE for everybody's benefit is this mixture of
MOE
experts.
for
Yeah,
mixture of
it's an
experts. Yeah,
architecture
so
style of neural network, which is basically transformer. I mean, transformer itself is like an architecture style of neural networks, right? So yeah, good.
So think of like a large model like a hospital. In simple words, you walk into a hospital and your end goal is to be either healthy, get treated for whatever the element you're checked in. Uh, so now you go into the hospital and you start with a general physician, and sure, you may say, you know what, you need to walk to a um, orthopedic because you come with a back pain, or you need to visit a cardiologist because you're running out of breath, or whatever it could be. Now, um, so the generalist sort of determines the direction in which you navigate through the hospital, and you have tooling, right? The way I look at tool calling is like nurses and the radiologists and the operators. They come and help you execute the various functions that a doctor might have measured, putting those equipment on your chest, measuring you, and then eventually you come out with a solution, hopefully by the time you're in a
Correct.
hospital. So the way you need to look at models is like hospital, and they are while for end user everything gets done, internally you talk to different experts in each of the function. The billing operator only doing billing, a micro MOE, it's a work to be done, and then you have the doctor, radiologist, so on and so forth. So that's how you can think of MOEs. The great benefit you get by using something like an MOE, like one person need not know everything per se, and she or he can be the expert. And it's a common architectural style today when developing models, so that one particular part of that model can have greater intelligence. Often all MOS need not even follow the same architecture theoretically. There's a router on the top, which sort of like helps you route your request through and orchestrate. So, yeah, in simple words, that's how we can
That's what MOE.
look at
So
MOE.
why are you excited about the Allen's work and the Open MOE work that you're doing?
Oh yeah, so like I think there are two open weight models that I have come across, but the Allen is open data, open weight, open model, open logs, and that sort of helped me sort of figure out. So the thing I was trying to do is like, in terms of memory footprint, today memory is the costliest commodity in the architecture. Can I swap one mixture at one expert at runtime? And that's what I was trying to chase for. So now let's say Alan's the experiment that we did, right? Like the 13 GB model, and can you run it within 2 3 GB? Because like there are about 4 billion devices already out there in the world, right? Everybody cannot afford to tag in a graphics card. So if you want to like sort of democratize intelligence, can we run it in the existing infrastructure, and the implications sort of like multiply? Not everything needs to be at the scale of DeepSeek or like Claude runs. A lot of small micro intelligence can be embedded in all existing ones. So I feel that since they open sourced it, I think it gave me the possibility to tinker with it. So that, and as a geek, I think that really got me excited about discovering Alan AI's work, and sort of deep diving into it.
Yeah, to wrap up today's session, what would you say?
Oh yeah, I think I want to like start the foundation for the next one as we wrap up. I think we need to dwell into what Anderson Horowitz has published. He Mark actually talked about a very intelligent, important paradigm, right? As we are talking about model scaling, but we have to also shift the paradigm to human scaling. Like I would probably end this with a thought, right? So now, like this is what Mark said, and then repeating his words. He said, as a project manager, now you believe that you can code. The other developer is not required. As a developer, you believe that you can manage better. So the project manager is not required. And the designer thinks, hey, these two, I can design better than these two. So other two are not required. But that's one way of looking at it. But uh, now that we have this wonderful tooling that's at our disposal, the real question to all of us is that, hey, what do we do such that we are relevant to others and relevant to the society and relevant to the organization where we work, in a way that our impact is multifold. AI is delivering that impact. So we talked about human versus AI benchmark. Hopefully we release that soon, but really that is not so far away. So it really begs the question on how we start putting together thinking models within others such that we think on delivering higher value. So I think on that, I think
Oh,
we should be
yeah.
the
I mean,
topic
now
of
I
this
understand what you
podcast.
said about scaling, right? I thought scaling means scaling the impact. First, you're saying is that, we need to become relevant, right? If AI and human become more and more intelligent, then this question of like just one person becoming everything, that Mark quote that you said, is like very, very like funny and ironical in some sense. So we need to figure out a way how to become relevant and then therefore be scale, right? So I tweeted today morning saying I see a lot of people complaining on the on LinkedIn and other social media saying there is too much AI slop. People used AI to come and write things on top of this, and I don't resonate. It is not human anymore. I think what has happened is that these AIs listen to that comment and then they built their own social network called Maltbook. Now human has to go and say that I'm a human. So even in Maltbook you have to declare yourself, right? I'm an agent or I'm a human. And
Yeah,
then they'll be like, you are too much slop. Don't come into my network, right? So that relevancy part, I think is something that we will have to rediscover
I don't
and
see that as a native, but
appreciate.
I think the way I look at it is this new benchmark, and we just need to sort of like we have evolved so well. I think we'll evolve faster, but uh, I think I'll go back to the original paper, right? Attention is all you need. So we need to figure out where, as humans, we need to place our attention, such that we one drive social value and economic value at the same time. So I think that those are the areas I strongly believe. Of course, there's a
Well
hint
said.
to what we're going to cover in the next podcast. Yeah.
Yeah, well said. Well said.
All right, then we'll call it a wrap. I'll see you all in the next one. If you have questions, do drop us a note like last time. And looking forward to see you all soon.
Yeah, see you guys.
Got a hot take on AI? A burning question? Let us know what you'd like us to debate next. And hey, if you want to jump in the ring with us, drop your LinkedIn link and the topic you're itching to discuss. We'd love to have you on the show.